Okay, this is video 2 for day 5 of the Solving Quadratics chapter. Here's where we're actually going to start using what we just did. So what we just did was called completing the square. We turned something that wasn't quite a square into something times itself. So we completed it, we made it a square. So what we've done in the past to solve quadratic equations is we factored or we've used the same or the square root method, but there's some times that we can't factor and we can't use the square root method and we need to know what can I do with this quadratic equation. What we're going to do is we're going to turn it into something that can be solved using the square root method. So stick with me, it'll make sense as we go along. So number 11 says x squared plus 10x equals 11. I want you to write it like this: x squared plus 10x plus blank is equal to 11 plus blank. I want you to notice that this side, just the left side, looks like x squared plus 10x plus c, which is exactly what we were doing above. That's what you're thinking. But whatever c is, whatever I put in that blank, I'm going to also have to put on this side, because when I add or subtract, I need to put whatever is on the left side on the right side. So that's the golden rule of algebra. Do whatever you do to one side to the other. So what I did for completing the square earlier is I said x and x. I want to know what to put here. So I take 10 and I can say that c is 10. I want to divide it by 2, which is 5. So that's what goes in my blanks here. And then to know what goes in for c, I'm going to square these two pieces, which is 25. But if I put a 25 on the left, I also have to put a 25 on the right. So then I have x plus 5 times x plus 5. 11 plus 25 is 36. And the nice thing now is that I can say x plus 5 squared is equal to 36. This is something that I can use the square root property for. So I can say, take a square root on both sides. X plus 5 is equal to plus or minus whatever the square root of 36 is. We happen to know that the square root of 36 is 6. And then I can write two equations. X plus 5 is equal to 6, and x plus 5 is equal to negative 6, because that's what that plus or minus means. Subtract 5 from both sides. And your final answers are x equals 1 and x equals negative 11. Number 12 is super similar, but I have this extra number sitting here. So the first thing I'm going to do is I'm going to get rid of that positive 8. And I'll say x squared plus 6x plus blank, whatever c equals 8 plus blank. My goal, again, is to get something times itself is equal to whatever the other side equals. I don't really worry about that. That's just what I'm going to deal with later. So I take 6, and the first thing I do is divide it by 2. So I get 3 and 3. And then to know it goes in the blank one step above, so I'm kind of working backwards, I've got to square it. So 3 times 3 is 9. Whatever I put on the left, I put on the right. And I get 8 plus 9 is 17. Now we've completed the square. We've already done it. X plus 3 squared is equal to 17. Now all I have to do is go ahead and solve. So this is old news. I take a square root of both sides, and I get x plus 3 is equal to positive or negative square root of 17. I want you to actually write two equations just so you get in the habit. X plus 3 equals square root of 17. X plus 3 equals the negative square root of 17. Subtract 3 from both sides. They're not like terms. So I get x equals negative 3 plus the square root of 17. Subtract 3, subtract 3. My second answer is x is equal to negative 3 minus the square root of 17. Oops, and I should have written that as a 17. I'm going to keep doing these problems. It's pretty much the same thing over and over. So once you watch a few and you feel like you can pause the video and try some of these, please do that. Number 13, I'm going to add 13 to both sides just to get rid of that number. It's like an extra number. M squared plus 12m. And then I'm going to say plus blank equals 13 plus blank. Because now I've got m plus something times m plus something. And I want to take that 12 and divide it by 2. I want to split it into those two parentheses. So that'll be plus 6 and plus 6. But then to find what goes in the blank, I have to square it. So I get 6 times 6 is 36. And 13 plus 36 is 49. So the big completing the square is m plus 6. Now it is something squared is equal to 49. Take a square root of both sides. Square roots and squares cancel. I get m plus 6 is equal to positive or negative. We actually know the square root of 49. It's 7. And this is actually why I want you to write two equations, because m plus 6 equals 7 and m plus 6 equals negative 7. We can actually find the two number answers here. So I can say negative 6 m equals 1, negative 6 on both sides, m equals negative 13. 14, what I really have to do here is say x squared plus 4x. I just have to add a plus blank on both sides, 0 plus blank. When I break this into two parentheses, I get x plus 2 and x plus 2, because I take 4 and divide it by 2. And I have to add, or I have to multiply rather, 2 times 2 to get 4 in my two blanks. So then 0 plus 4 is 4, and completing the square is x plus 2 squared equals 4. Okay. Again, now I'm at the point where it's old news. This is stuff I've already done. Take a square root of both sides. X plus 2 equals plus or minus 2. X plus 2 equals 2, and x plus 2 is negative 2. So then I subtract 2 from both sides, and I get x equals 0. Subtract 2 from both sides, and x is equal to negative 4. Number 15, I want to complete the square, but I've got an extra 10. Get rid of that 10. X squared minus 10x plus blank is equal to 1. I get x and x. I want to know what goes in the parentheses first of all. So break up the negative 10 into two pieces. Negative 10 divided by 2 is negative 5 and negative 5. Square both, or square the negative 5 to get what goes in the blank, which is 25. And then 1 plus 25 is 26. So completing the square is x minus 5 squared equals 26. And now I can just go to town with my square root. Take a square root on both sides. X minus 5 is equal to plus or minus square root of 26. I should always double check to make sure I can't break down my 26, but 13 and 2 I'm not going to have any pairs, so that's okay. Add 5 to both sides. I can tell that I don't have like terms, so if you don't need to write it into separate equations, that's okay. I should get x is equal to positive 5 plus or minus the square root of 26. But if you wrote x equals 5 plus the square root of 26, x equals 5 minus the square root of 26, that is a perfectly correct answer as well. 16, again, this 10 is extra, so get rid of it. X squared plus 6x plus blank equals 27, and then plus blank. I want to know what goes in there. So I get x plus 3 and x plus 3. Because 6 breaks up, 6 divided by 2 is 3. And then I have to square 3 to get what goes in my blank. So I get 9 in each blank. 27 plus 9 is 36. And the final completion of the square is x plus 3 squared is 36. Go to town on your square roots. So I square root both sides. And x plus 3 is equal to plus or minus. We know the square root of 36 is 6. So on these problems, when you know you're going to have like terms, write out two equations. X plus 3 equals 6. And x plus 3 equals negative 6. Subtract 3 on both sides. If you are just checking your answers with us, double check. Make sure that all of these answers make sense. I did go through every step on all of these. You should always get two answers every single time, unless it's a double answer. So that'll come up when you have your two answers for your equations are the same number, and that's okay, but you should always be solving two equations at the end. Sometimes you will get the situation where your leading coefficient is not 1, meaning we have this kind of thing, a 3 out front. So what I'm going to do first of all is still get rid of this 12 because it's not helpful to us right now. And I have 3x squared minus 6x plus blank is equal to negative 12. When I complete the square, I really can't do much right now. What I want to do is I want to factor out a 3 from everything. So I'm going to take the 3 and say x squared minus 2x plus blank is equal to negative 12 plus blank. The reason I do this is because I know how to complete the square on something like this. Okay, so what I do, the 3 stays along with me, but I can break up that negative 2. Negative 2 divided by 2 is negative 1 and negative 1. And what goes in the blank is that number squared. Negative 1 times itself is 1. But whatever I add to the other side is actually going to be 3 times that number. Because think, if I were to distribute that 3 through, what I really added to that side was 3 times 1. So I'm going to put a 3 on this blank. Okay, or maybe 3 times 1 is a better way to think about that. So then I get negative 12 plus 3 is negative 9. So then I've got 3 times x minus 1 squared is negative 9. And I can finish solving my problem. So I divide by 3 on both sides. I get x minus 1 squared is positive 3, or negative 3, excuse me. And when I take a square root, we'll notice here we get x minus 1 is equal to plus or minus the square root of 3 times I, because there's that negative under the square root, so that's from last class. Then we can add 1 to both sides, and we'll get x is equal to 1 plus or minus the square root of 3, I. So mostly I just want to show you this number 17, that we still can complete the square when the leading coefficient isn't 1. But these problems are the ones that I need you to know, like for your test. The other cool thing with completing the squares, we can actually use this to write our functions in vertex form. So if I want to complete the square here, what I can do is I can still get rid of this 8. I can say f of x plus 8, so I'm adding to both sides still, is x squared plus 6x plus blank. And I'm still going to have a plus blank on that left side. So then I've got f of x plus 8 plus blank is, I've got to break up this side. So I have x plus and x plus. 6 divided by 2 is 3. So then I can take 3 times 3, and what goes in my blank is 9. So 8 plus 9 is 17. And I get f of x is equal, plus 17 is equal to x plus 3 squared. Now what I can do is I can take that 17 back, and I have f of x is equal to x plus 3 squared minus 17. The thing that I've done now is I've put this in vertex form, which we know we can use to graph our parabola. Our vertex is going to be -3, comma, -17. This one faces up. The width is normal, and the axis of symmetry is -3. So that's really all we're going to do with our completing the square. Again, number 17 and 18, I wanted you to see how this could be used, but we are going to focus for quiz and test questions on numbers like 11 through 16. So those are the ones that I want you to be really prepared on.